vibration. They may affect the stability of the excavation.
Visual tests can provide some qualitative information concerning soil types. The accurate designation of types A, B, or C soil also depends on what is called the unconfined compressive strengths of each type of soil. This is the load per unit area at which a soil will fail in compression.
Type A soils have unconfined compressive strengths of 1.5 tons per square foot or greater. Type B soils have unconfined compressive strengths less than 1.5 tons per square foot, but greater than 0.5 tons per square foot. Type C soils have unconfined compressive strengths of 0.5 tons per square foot or less.
Plastic means a property of a soil which allows a soil to be deformed or molded without cracking or appreciable volume change. The soil's plasticity can be determined with two tests, the thread test and the ribbon test.
In the thread test, a sample of soil is rolled into a ball and then into a thread. The longer the thread, the more cohesive the soil. If it breaks apart, that indicates granular material, and the soil could be type C. In the ribbon test, the ball is rolled into a cigar shape, then pinched into a ribbon. The longer the ribbon, the more cohesive the soil. If the ribbon breaks off in chunks, that indicates the presence of granular material. The dry strength test is used to determine the approximate strength of a soil sample. How difficult a clump of dry soil is to break up or crush is related to its cohesiveness. The harder it is to break it or crush it, the more cohesive the soil is. In the thumb penetration test, you determine how difficult it is to push your thumb into a large clump of freshly excavated soil. Type A soils will be only slightly indented under pressure. If only moderate effort makes a dent, that could be type B soil. Type C soil is easily indented. The pocket penetrometer test directly reads the unconfined compressive strength of a soil. The penetrometer is pushed into the soil sample to the red line, then pulled out and read. The reading in tons per square foot will indicate whether the soil sample is type A, B, or C. The Torvane shear test finds the shear strength of a soil sample. The reading is in kilograms per square centimeter. Multiplying the reading by 2 will convert it to tons per square foot, a number that can be compared to the OSHA specifications. An average of several findings is required for an accurate determination. However, if there is water accumulation or seeping water, the problem must be eliminated or removed. Otherwise, it doesn't matter what the soil tests have indicated. The soil must be classified as type C.
The competent person now has collected a large body of information: the soil type, the location of utilities, the size of the equipment available, the space available at the site. The competent person knows the depth and size of the excavation and is familiar with the protective systems. Now the appropriate protective systems has to be selected to protect the employees who will work in the excavation.
These protective systems could include sloping or benching, shoring, and trench shields. Sloping and benching are methods of cutting back the vertical dirt wall of an excavation in order to prevent the soil from sliding or falling into the excavation. Slopes are determined by the soil type. Type A soil requires a 3/4 to 1 slope. Type B, a 1 to 1 slope. Type C, a 1.5 to 1 slope. With cohesive soil, the slopes can be broken into a series of horizontal levels or steps, usually with vertical or near vertical surfaces between the levels. This is called benching. There are additional options in Appendix B of OSHA excavation standards. Shoring is a method of using either wood or aluminum members to prevent vertical trench walls from falling into the trench. The members must be of the proper size and spacing in order to effectively hold the soil walls back. This is determined by first classifying the soil. OSHA Appendix D lists two types of aluminum shoring: vertical uprights and whale systems. Each has its own advantages. Again, proper soil analysis is essential before spacing between cylinders can be determined. Trench shields are boxes made of steel or aluminum components, inside of which employees work. While the box doesn't prevent soil collapse, it does protect workers from the collapsing soil. Trench boxes are rated to be used at various depths depending on soil type.
As an alternative to using the standard systems, an employer can hire an RPE, a registered professional engineer, to design a protective system and provide charts and diagrams that explain how the engineered system is to be used. Even with the protective system in place, the excavation is not ready to be worked in.
First, a safe way into and out of the excavation must be provided for employee use. A stairway, ladder, ramp, or other safe means of access and egress must be included in any excavation or trench 4 feet or more in depth.
Any means in and out must be located so that an employee doesn't have to travel more than 25 feet to reach it. One further step must be taken before anyone can work in the excavation.
The competent person needs to examine the excavation for hazardous atmospheres. Primary atmospheric hazards include low oxygen levels, a flammable atmosphere, and toxic environments such as carbon monoxide.
Some causes of these hazards include nearby utilities like sewers that contain gas or liquids, and nearby landfills or swamps can create dangerous atmospheric conditions, in addition to nearby traffic. When the competent person determines that the atmosphere in the excavation is not hazardous, then work inside it can begin. To protect employees and public pedestrians, the employer needs to provide for fall protection. That means putting up guardrails on ramps over excavations. And many excavations should be guarded with barricades or fencing to keep out children and the unsuspecting public. As work goes on, inspections are required every day before work begins. Inspections are also required after rainstorms. If the excavation is subject to periods of heavy vibrations, such as from passing trains, pile driving, or heavy traffic, inspections of the excavation should be made frequently. And if there are conditions nearby that could produce hazardous atmospheres, the air in the excavation should be monitored throughout the day.
Inspect for water daily. Never let water stand or accumulate in an excavation. Always have water removal equipment ready and in working condition. In general, inspections should be made and documented as needed throughout the day. If any hazards are found, they must be eliminated before work can proceed safely again.
Emergency situations usually occur suddenly and without warning in excavation work. Emergencies include soil collapse, protective system failure, material or equipment, or an employee falling into the excavation, hazardous atmospheres, and utility contacts. Because many fatalities occur when workers improperly try to rescue co-workers, every construction site should have an emergency action plan.
The competent person should contact the contractor to become familiar with the proper procedures to be followed in the event of such an emergency and inform all employees of these procedures.
Now it's time for the completion stage of the work. Safety is still a prime concern. When the protective system is removed, monitor for soil movement and backfill as soon as possible. Maintain the barricades and signs as the completion work continues. Note unusual occurrences for future reference and any problems that may have occurred. They may suggest that the safety plan must be modified.
From the beginning to the completion of the work, make sure that the soil analysis, daily inspections, and selection of the protective systems are done by a trained, competent person and fully documented.
The documentation is insurance that an OSHA inspection will find the job is being done according to the OSHA standards. But more important, it will be evidence that you've made safe excavation conditions your primary concern. And there's nothing more important than the safety of your workers on the job.